as with all of our conic sections, the first graph is always what we call your parent function. Okay. And you'll notice that nothing is being added or subtracted, nothing's being multiplied or divided. So where do you think your center is going to be at? 0, 0, okay? So at 0, 0, we're going to put a little point there, okay? All right. So while it looks like you're not dividing by anything, you're actually dividing by 1 and dividing by 1, okay? And when you take the square root of 1, you get 1, okay? That means your vertices are going to be 1 unit each direction, okay? And so a hyperbola is either going to open up and down or right and left, okay? So the way to tell is which variable is first. So notice right here, this one starts with the x squared, then minus the y squared. Notice number 2 starts with y squared minus the x squared. So the ones that start with x squared are going to be your horizontal, which means they're going to open left and right, okay? So the one that starts with y squared is going to be your vertical openings, which is going to be up and down, okay? Number 2 also doesn't have anything being added or subtracted, so its center is also going to be at 0, 0. Bless you. Okay? So if we're starting at 0, 0 on number 1, and we're going to open right and left, so from this point, we're going to go 1 to the right, put a point, 1 to the left, put a point. Then we're going to go up 1 and down 1. In this case, it's going to make a square. Okay? In most of the hyperbolas, it's going to make a rectangle. Okay, so watch. We're going to draw a rectangle, or in this case a square, that goes through those 4 points. And that's going to be the outline of where we're going to draw our hyperbolas. Okay? Then you're going to go to opposite vertices, right? So this vertice and this vertice, and you're going to draw a line, and I'm going to use my highlighter for this. So I'm going to use yellow, but it doesn't matter what color you use. And then go to the other pair of opposite vertices, draw a second line, and that's going to be your guide, or what we call your asymptotes. And it's spelled kind of funny. It's ASYMPTOTS, asymptotes. And you've got 2 of them. Okay, that's your guide. Okay. Once you have your asymptotes and you know it's going to open left and right, you can sketch in your hyperbolas. So the hyperbolas are going to have a vertex right at that point, and they're going to get super close to your asymptotes. And that's the left side of your hyperbola. And you're going to do the same thing on the right side of the hyperbola. Okay, these 2 points are called your vertices. So we have one at positive 1, 0, and we have one at negative 1, 0. Because this one's opening left and right. If it had opened up and down, it would be at 0, positive 1, and 0, negative 1. You guys see that? Okay. All right. They're also going to ask you for what is the length of the transverse axis and what is the length of the conjugate axis. We did something similar with the ellipses, right? So in this case, they're tied. Usually the longer one's going to be the transverse and the shorter one's going to be the conjugate. But since they're both 2 units, you just write 2 and 2. All right, so the last thing we need to do is find the foci, which is basically 2 points that are going to lie within the hyperbolas. So somewhere in this space, we're going to have a point, and that's what we're going to use the other color highlighter for. And on matching on this side, we're going to have a second one, okay? So we're going to use c squared equals a squared plus b squared. And in this case, that's the square roots of the denominator. So if square root of 1 is 1, we're going to have c squared equals 1 squared plus 1 squared. 1 squared is 1, 1 plus 1 is 2. So if c squared equals 2, then c is the square root of 2. Now, if it's a perfect square, you're going to end up with a nice number. If it's not a perfect square, get the approximate decimal. Just type it into your calculator. You type in square root of 2, you should get something close to 1.41. Almost 1.5. And so when you're graphing on a coordinate plane, this is so small, right? I mean, if you could blow it up and make it super huge, you could probably get really close to where 1.41's at. But on a graph this small, 1.41 is roughly 1.5, right? Okay. So from the origin, or from the center, because the center won't always be at the origin, but from the center, you're going to go 1 and almost a half units. So I'm going to put mine in pink. You can kind of see it's right there. And then you're going to go 1.5 units to the left. So there's 2 points. These are called foci, right here and right here. So underneath it right here, I'm going to put that I put them in pink. Whatever color you use, I would write, you know, if you use green, write green. If you use yellow, write yellow. Okay? So you want to do your asymptotes in one color, and you want to do your foci in another color. Okay? So your asymptotes are yellow, or whatever color you use. Okay? So it's always, whenever you do the parent function first, it's kind of limited because you're dealing with zeros and ones. Okay? So once I do number 2, it'll kind of be a little more movement on it. Okay? So bear with me for number 2. So this is standard form, obviously, where if something's being added or subtracted, that's going to move your center. And the denominators, their square roots, just like with the ellipses, is what's going to stretch it one way or the other. Okay, does that make sense? All right, so obviously the center is at 0, 0, so go ahead and put a point there. This one starts with y squared, so we already wrote down that it's good. The hyperbola on this one are going to open up and down instead of right and left like they did on this first example. Okay, so let's talk about what's happening on the y-axis. So you'll know what's happening on the y-axis because the denominator will determine what's happening on the y-axis. And what's happening in the denominator of the x term is what's happening in that denominator. So if you take the square root of 25, you're going to get 5, right? And if you take the square root of 4, you get 2. So on the y-axis, you're going to go 5 units each direction, okay? And I don't want to say origin, I want to say the center just happens to also be the origin. You're going to go up 5 units. 1, 2, 3, 4, 5, put a point. And then down 5. 1, 2, 3, 4, 5. Okay? Which makes that transverse axis, bless you, that's going to be the longer one, right? So your transverse axis is going to be 10 units. Okay. Then on the x-axis, because its denominator is 4, we take the square root. So 2 units each direction. So from the center, go 2 units each direction. These 4 points are what's going to give you your rectangle. Okay? And the book says to dash it. And you can dash it if you want, but for me it's just faster to just do a solid line because dashing takes longer. So I just make my rectangle using those 4 points. Okay, but if you feel like dashing it, go ahead and dash it. Okay? Now I'm going to draw in my asymptotes using a highlighter. Okay, the asymptotes, remember, are your guide. So go from opposite vertice to opposite vertice. And then get the other one as well, so you make a big X. Those are just the guides for the hyperbola. So now you're going to use this point because it's going to open up and down. So this point is going to be your vertex, and this point is going to be your vertex. So this time, it's at 0, positive 5, and 0, negative 5. And you're going to draw in, getting super close to the asymptotes, making what looks like parabolas, but they're called hyperbolas. They kind of sound the same, parabolas and hyperbolas. They kind of have that same ring to them. So because the y term came first, we're going up and down on these instead of right and left. Okay? The longer axes, the transverse axis is the longer one, so it's 10 units. And the conjugate axis, the shorter one, was 2 units, so double it, you get 4. Okay? Now all we need is that foci point. And it's going to be in this area somewhere, and then you're going to have a symmetrical one in this area somewhere. So let's do that equation. So it's c squared equals a squared plus b squared. So I'm going to do 5 squared plus 2 squared. 5 squared plus 2 squared, so 25 plus 4, which is 29. And then take the square root of it. So if you do it in your head, you're like, okay, it should be a little more than 5, right? But if you punch it in your calculator, you're going to get something close to 5.39. So roughly 5.5 on this small of a graph. If you do about halfway between 5 and 6, it's going to be close enough, right? All right, so start with the center. Just also happens to be at the origin, but when we start moving it around, always go to the center, go 5.5 units up. 1, 2, 3, 4, 5.5. So it's just on the other side of the vertex. And 5.5 units down, so just right there.